everyone. Today in our lecture we are going to discuss about multicollinearity. Multicollinearity is a problem that comes with regression analysis, and it is one of the most important assumptions that we want to satisfy before performing any regression analysis. Thus, today in our agenda, we first start with explaining what is multicollinearity, and then we discuss about what are the causes of multicollinearity. Now, if there exists some multicollinearity, then what are their consequences? Next, we outline how we can detect multicollinearity, and lastly, we finish with one demo example explaining the process by which we can detect multicollinearity in SPSS. What is multicollinearity? Let us take one example where y is our dependent variable and x1, x2 up to xn are our independent variables, and e is the error term. Then this multiple linear regression model exists multicollinearity if two or more independent variables in the model are highly correlated. Causes of multicollinearity, including variables that capture similar information, is first cause of multicollinearity: inaccurate or imprecise measurements of independent variables, or taking too small sample sizes are another cause of multicollinearity, including a large number of variables without proper justification or omitting important variables are another causes of multicollinearity. Consequences of multicollinearity. If there exists some multicollinearity, then it creates problem in our regression model. These problems are outlined here. First one is that the variances and covariances becomes infinitely large. Second one, least square estimates become indeterminate. Third one, type 1 error increases. And the fourth one is we get a very good R-square value, but no statistically significant regression coefficients exist in the model. Now, how to detect multicollinearity? Multicollinearity can be detected using VIF, that is Variance Inflation Factor. VIF measures how much the variance of the estimated regression coefficients is increased due to multicollinearity. If VIF is equal to 1, then there is no multicollinearity. If VIF greater than 1, then there is a presence of multicollinearity, but the multicollinearity is not that much severe. But if VIF is greater than 1, then there is high multicollinearity that we need to be addressed. For the purpose of explaining how we can detect multicollinearity in SPSS, we take one demo dataset where dependent variable is taken as dose lib, that is dose that reached the liver of a rat, and the independent variables are weight of the rat, liver weight of the rat, dose that fed to the rat, age of the rat, and the last independent variable is whether the rat is pregnant or not. If yes, then we take 1, and if not, we take it as 0. Now we open our SPSS window for performing multicollinearity test. For performing multicollinearity test, we already entered the data in SPSS, and after entering the data in SPSS, we need to click on Analyze. From Analyze, we go to Regression. In Regression, we select Linear. Then two boxes is going to be open. First one is dependent variables box and second one is independent variables box. Since our dependent variable is dose_lib, so we select dependent variable dose_lib and move this variable into the dependent variable list and select all other variables and move them to the independent variables list. Now we need to click on statistics. Here two boxes are checked. First one is estimates and second one is model fit. We uncheck both these boxes since we are only concerned with testing multicollinearity. So we check the multicollinearity diagnostics box and click on continue, and then we click OK to get our results. Here two tables is going to SPSS. Here SPSS is going to provide us with two tables. First one is coefficients and second one is collinearity diagnostics. In coefficients we see that for weight of the rat and dose that fed to the rat, the VIF is more than 10. So there is a potential possibility of multicollinearity in our data set. Now to get an idea that which variable is creating the problem of multicollinearity, we look at the collinearity diagnostics table and identify the dimension where simultaneously value of variance proportion for two variables is more than 0.5. Thus, for our data set, we identified that in dimension 6, variable proportion for weight is 0.99 and dose that fed to the rat is 0.98. Since weight is contributing more variation in the model, thus we exclude the variable weight from our model and run the collinearity diagnostics again for checking whether other variables are creating multicollinearity among them. To test the multicollinearity again by excluding the variable weight, we follow the similar steps. For this, we need to click on Analyze. From Analyze, select Regression and then select Linear. Here, we select the weight, independent variable weight, and move this independent variable to the independent variables list. Now we have dependent variable as dose_lib and independent variables are liver weight, dose that fed to the liver, pregnancy of the rat and age of the rat. Now click on statistics, select the collinearity diagnostics box, click continue and finally click OK to get the modified multicollinearity test results. From first table, that is from coefficients table, we see that for all the independent variables, the VIF is less than 10, which conclude that there is no high level of multicollinearity among the independent variables. Since VIF for all the variable is less than 10, so we are not going to look at the collinearity diagnostics table, and from the coefficients table we conclude that our model is free from multicollinearity and are ready for regression analysis if two other assumptions, that is autocorrelation and heteroscedasticity, is satisfied. Thank you for listening to me. Kindly like and share my video and also subscribe our channel